So, here we are going to discuss in this class the dune classification in continuation of our earlier class. If you remember, when we are talking about this dune classification, we are talking about these longitudinal dunes, transverse dune, star dunes, parabolic dunes, like that. So, all those dunes, they are defined by this wind blown direction and with respect to their structures. So, longitudinal dunes, they are parallel to the wind blown direction, transverse dune, they are perpendicular to the wind blown direction. Similarly, within the transverse dune we have Barkhans, we have parabolic dunes, and we have other type of dunes like the star dunes is a special kind of dune which shows different wind blown directions, and it grows in height rather than it migrate. So, this was all about your dune classification. So, today we are going to discuss some other aspects of the dune classification. Here if you see these two gentlemen Koruk and Hablon, that 1993 defined there are the dunes can be classified by dry, wet and stabilized eolian system. So, what is this dry eolian system? This dry eolian system, if you see three photographs representing these three scenario here, this is the dry system, that means free sand, free movement of sand, there will be no moisture at all, no vegetation. So, that is called dry area, that means dry sand is there. Then wet, if you migrate from here to here, these photographs you see this is the playas, and near to this playa we have certain vegetation, that means this area is wet. Then third is your stabilized system. Stabilized system, it is either it is artificially or it is naturally. You see, whenever there is a arid environment, dunes migrate frequently, and this dune migration creates a problem in our developmental projects. It may encroach the whole village at time. So, that is why there are certain programs through which either naturally or artificially we always try to stabilize the eolian system or stabilize the dunes. So, in that case there are two ways of stabilization. One and the most effective way is the vegetation. So, once we allow the vegetation to grow on the dune surface, the wind's effectiveness will reduce, and finally, there will be less migration or there will be no migration of the dune further. This is called totally stabilized dune. And other factor is their water table. So, if we have water table close to the surface, so that means by capillary action this water will move upward, and finally, the sands, the adhesive force between this sand will increase, and finally, this will resist to blow by wind blown. So, that is why in that case what we this case is called stabilized system. So, that means now we have dry eolian system, wet eolian system and stabilized eolian system. So, each eolian system that plays a characteristic role, either they will allow this dune to form or they will not allow the dune to form, that will be discussed here. Now, then another part is your coastal dunes. If you move in the coastal area, there is a peculiar type of rock types is called aeolinite. So, aeolinite is nothing, it is aeolian sediment and it is mixed with organic matters, and the organic matter it may be of animal origin, it may be of plant origin. So, irrespective of that, but mostly this animal origin are calcareous material like this broken part of the cells or so. So, that means the organic matter together with the sand, they consolidated recrystallize very soon to form a material which is intact and consolidated, that is called aeolinite. Now, you see coastal sand dunes commonly include large portion of biogenic calcareous sand that is readily cemented as aeolinite. So, if you see these two photographs, this is mostly calcareous materials and along mixed with sand and forming a hard pan here. Similarly, here it is hard, but mostly it is porous and highly permeable. So, the whole system is called aeolinite. Then another structure is called wallbacks and Gibber dunes. So, what is wallback? It says if you see a wall from a distance, the back it look like this. It is, if you see this type of it will see, you see this is the type of topography, that is called rolling topography. So, how it happens? So, suppose for example, we allow the sand to move, or a sand dune, a longitudinal dune to move in a particular corridor. So, once we know this sand is, or the dune material is moving, relatively finer material will move fast and the coarser material will lagging behind, and finally, the boulders, the pebbles, the cobbles, that will lagging behind in the system. And with continuous addition of this material, or if we allow the material to move continuously for a long period, then with more and more lagging material will be accumulated there. So, as a result, with more time, so this type of topography will form, that is called rolling topography, very gently sloping surface, that is called rolling topography. So, here the longitudinal dunes have migrated downwind, the coarser sand is left behind as a prominent low rolling ridge of coarse sand lacking of a slip face. As it is very gently sloping plane, it will not create any distinct slip face here. These wallbacks or Gibbard dunes attest to the stability of longitudinal dunes in the form and space over long periods. That means, a long period this type of this longitudinal dune will be stabilized here, or it will move along this same, through the same corridor for a long time. Either very large longitudinal dunes migrated a long distance downwind, or longitudinal dunes repeatedly followed the same path across the desert in order to leave these large residual ridges. So, now if you see this photograph here, this is a zone, this is a linear zone, which is the, through this linear zone we are concentrating these pebbles, cobbles, or the larger boulders also. So, that means it indicate through this path, or through this path we have allowed to migrate a longitudinal dune for a long time, or the reverse is true, that means through this path there are number of longitudinal dunes they have passed through. So, as a result, addition of material, lagging material is there. So, as a result we will create a surface which is looking like this, that is very gentle sloping body, that is called the rolling topography. So, this is all about our dunes. Now, we will discuss about this undulating or fixed sand sheet. Now, let us discuss about the sheets, sheet type of structures. So, here undulating fixed sand sheet, that means there will be some undulation, this is not planar, it is undulation. See, undulation might be due to blowout, due to vegetation, or the presence of some coarser and finer material, or that means accumulation of more sand at a place or less sand at a different place. So, that means irrespective of its nature, it is creating an undulating topography having some thickness. That means, that is why its 2 dimension is more as compared to the 3 dimension. That is why it is calling a undulating sand sheet type of structure. So, these type of structures, this undulating sand sheet, that is mostly that are common in the semi-arid type of regions, like the semi-arid steppes and prairies, especially in the middle latitudes. So, interior of the middle latitudes, or in the middle latitude or interior of this large continent, they are underlain by sandy sediments, have sparse grass cover and have intermittent rain or winter snow. So, those areas having sandy sediment is there, grass cover is there, but sparse grass cover is there. So, there will be sand movement, but that movement is in restricted form. So, that means selective spatial movement, that means some spaces where lack of sandy cover, that from that area sand will blow out and this blowout sand will deposit somewhere else. So, that means if you see from a distance, you will find this type of topography, that means undulating topography. This represents the lower portion, that represents the blowout regions, and the upper portion they represent the deposition regions. As there is no sufficient sand supply and the vegetation is there, so perfect dune cannot form here. So, that is why it remains as a sheet format. That is why it is called undulating fixed sand sheets. Local areas of shallow deflation basins develops alternating with subdued parabolic dune forms. You know, when we are talking about dunes, we are talking about when there is vegetation is available, when blowout is available, we generally those areas are suitable for generation of parabolic dunes. So, here the same condition satisfied. We have vegetation cover, we have sand. So, we are allowing the sand to blow. So, that means we are creating some blowout surfaces. That is why local areas of shallow deflation basins develop alternating with subdued parabolic dunes. So, we are getting some parabolic dunes here. Winds are not sufficiently active to create dune with active slip faces, but the combination of deflation and deposition makes the landscape of undulating hills. If you see here, we have some blowout areas, material is removed and depositing here. Similarly, material will remove and depositing here. So, that is why we are creating an undulating topography here. Similarly, if you see here, we have some areas from where this blowout occurred and finally, sand is deposited here. So, overall it is creating an undulating topography. And if you see here, this total sheets says about this combination of different wind blown direction and sand supply, and summarizing how the sand dunes are formed, and this is the transverse and this is the longitudinal dunes, this is our parabolic dunes and this is Burkans, this is star dunes and this is the dune how the dune migrate, this is internal structure is shown here. So, this is all about the summarizing sheet or the summary sheet of this dune we have so far discussed. And here as we are expecting that there are three main factors, they are responsible for dune form, their effective role is discussed here. Now, you see we have a triangle having three vertices, one is 100% vegetation. So, 100% vegetation, that means we are allowing a dune to stabilize or the area which is a stabilized area. That means, it is providing sufficient cover or sufficient resistance to wind to remove a sand particle from its surface. So, here we have 100% wind, that means very high wind speed is there. Then it is 100% sand supply, that means sand supply is sufficient for that. So, now you see if we are confining in these two parts. So, here we are getting transverse dune where maximum sand supply is there, massive sand supply, that wind here 100%, then if the wind blown is 100%, then we are creating longitudinal dunes. Here we are getting transverse dune and here this portion we are getting parabolic dune. But if you see here in this region no dunes, that means you see we have 100% vegetation and we have sand supply. If it is sand supply is there, vegetation is there, there will be no dune form. Similarly, wind speed, if it is less wind speed, this side wind speed is less. So, those sand supply will be there, but less wind speed, then dune will not form. So, that means these three factors that with different permutation and combinations, they collectively decide whether the dune will form or not and what type of dune will form or not. Okay. So, this is all about your sand dunes. Now, come to sand sea or earths. Sand sea, that means if you see this is representing thousands of square kilometers of area, it is covered with sand. So, that means 20 to 45% of this arid region of the world consist of vast sand seas or that is called earths. Their surface consists of a variety of dune forms ranging from these mounds of huge star dunes and ripples like that. So, that means I want to say this whole area, a whole arid region, it is composed of totally sand and this is, that means it is looking like a sand sea, ocean of sands. This is called earths. So, these areas mostly some, that means those areas which are representing sand seas, there are certain factors which are responsible for its accumulation and the most prominent factor is the lithology. How lithology plays major role in accumulating of the sand we will discuss here. Now, Wilson 1973 suggested a preliminary definition of an urge, that an area where wind led sand deposit cover at least 20% of this ground and which is large enough to contain drass. Drass we know it is a huge sand body, it is sand dunes type. A minimum size range from 1 to 40 square kilometer area. Sand is thick and continuous enough to the surface to include the full size range of aeolian landforms like ripple, dunes and drass. So, that means a sand sea, that means a huge area having sand, then that can accommodate ripples, dunes and drass. That means all kind of aeolian landforms, all kind of movement structures of the sand there can be accommodated here. So, this is the characteristics of drass, that means all type of aeolian structure will be available. These largest of all sandy landscapes are fixed primarily by lithologic factor. Here we are talking about the lithology plays a major role in accumulation of sand in a particular area and creating a sand sea. How? If you compare here, those in Africa, Arabia and Australia are on the downwind form easily weathered sandy sedimentary rocks probably deposited in Cenozoic or Mesozoic marine environment and freshwater lakes. So, that means if you discuss the, if you analyze the terrains of these different surroundings and compare with this sand sea, you will find the source area which is surrounds in the upwind direction, which is mostly the sedimentary rocks, either quaternary or in the Mesozoic form, and they are unconsolidated to semi consolidated. So, that means if this wind is allowed to blow on sedimentary rock which is unconsolidated or semi consolidated sedimentary rock or weathered sedimentary rock. So, that means mostly that will bring the sand, that will remove the sand from this system and will accumulate somewhere here. So, had it been basalt, covered with basalt, had it been covered with granite, probably such huge sand sea might have not occurred. So, that means the surrounding lithology plays also an important role, whether what will be the area and what should be the spread of this sand cover. Some sand seas show evidence of quaternary episodes activity induced by climatic and sea level fluctuation and tectonism. So, that is also important. Tectonism, we know that tectonism is playing major role in producing sediments. It is more fractures, more upliftment will be there, more fractures will be there, more sediment degradation will be there, and finally it will be removed. Similarly, sea level changes. Sea level, if it is sea level is decreasing, then it is creating sediments. If its sea level is increasing, it is creating another kind of sediment. Similarly, climatic change, arid region, it will create more sediment. So, that is why tectonism, sea level change, climatic change and the surrounding lithology, all those they play their respective roles in producing sediments, and finally, those sediments were transferred and deposited and forming the ocean of sand or sand seas. Wind transport and deposition constantly shift the surface layers, but the regional landscape is one of this awesome monotony. So, that is why by shifting the sands, by transporting the sands from the surrounding area, we are creating a sandy dominated area or sand dominated area, and through this wind movement we are deforming the sands, we are creating one type of topography, again we are migrating these dunes, we are migrating the ripples, creating another type of topography, and finally, this area is mostly dominated by wind driven sediments and its deformation and its rearrangement. So, what we were talking so far, we are talking about the dunes, the ripples like that, these star dunes XYZ something. So, that means in all those structures we were involving the sands itself, but what about the fine products? Because whenever there is weathering, when there is erosion, when there is sediment production, not only sand particles are created, silt, clay, that means finer size particles are also created. So, it is the part of this work of this wind which transport all those materials and deposit at a place. And if you remember when we were talking about this shutting, due to this saltation, due to the suspension, due to this traction or this creep, different size fractions we separate out. And in desert mostly the coarser fraction remains, and once the wind velocity or wind speed decreases at the periphery of this desert system or a reed system, this sand is not able to be transported out of the system. It will remain inside, it will migrate here and there, it will create different landforms. However, the finer particles, this silt and clay sized particle, they once they come to suspension, they remain in the suspended for a longer time. It is very difficult to pick out a silt or clay sized particles from this intact surface, but once it comes out, once its system is steered, that means it will remain in suspension form for long time and it can migrate thousands of kilometers. Okay. So, however, if this steers into suspension, dust can lift hundreds of thousands of meters into the air and carry long distances. So, as we have discussed in our earlier classes, this volcanic ash deposit in Narmada Valley, it is related to Toba volcanics, that means it is 1000 kilometers apart. Similarly, these aerosols that can travel thousands of kilometers through this globe. So, that is why this silt and clay sized particle, once it peaks up to the air system, it will continue travelling for long distance. Dust that has been transported for distance of less than 100 kilometer has grain size of silt range. Dust stays in suspension as an aerosol and is precipitated only by rainfall. It is mostly of clay size. So, the aerosols mostly of clay size particles, and the silt mostly it is by lowest deposits. So, lowest deposit mostly in our Indian context, if you see in Punjab, Haryana, it is in the periphery UP, in the periphery of this third desert, we are getting lowest deposits. Fine wind blown dust is the major component of deep sea sediments also. Deep sea sediments, when we are talking something about deep sea sediments, some of the sediments are biogenic origin, some of these origin are chemically precipitated, and mostly it is a major component of this deep sea sediment is of wind or aeolian origin. These are the aerosols, these are the finer particles, they settle down there. Due to moisture effect, they becomes heavy and finally they settle down. So, this major component of the deep sea sediments, the Sahara is the major source for the equatorial Atlantic Ocean. So, if you see this, analyze the source of this Atlantic Ocean sediments, deeper ocean sediments which of aeolian origin, and it is mostly picked up from the Saharas. And Central Asia contributes most of the dust to the North Pacific. The Central Asia and Sahara, that means major arid systems, major arid regions, major desertic regions, they are creating this silt and size particles, and it travels to thousands of hundreds of kilometers and they are settled down in the oceanic surface. Dust from Central Asia is seasonally collected in Hawaii, and Saharan dust is a major component of the soils on limestone in the Caribbean region. So, if you see here, this is not only contributing for these oceanic sediments. If you remember when we were talking about this weathering and erosion, and we are talking something about the calcrete formation, you can remember calcrates or these soils, the carbonate, calcium carbonate soil, maximum part it is contributed from this wind blown material. So, these are the fine grained particles of calcium carbonates, the sand particles or sorry the silt and clay size particles, they are deposited there and forming a calcrete layer. So, it not only contributes to the ocean sediment or deep ocean sediment, it contributes to the soil forming processes also, the soil formation, soil thickness, soil horizon thicknesses also. During Pleistocene cold interval, dust was more abundant in the atmosphere, reaching 3 to 5 times more abundant than interglacial time in the northern hemisphere. It is estimated that means during interglacial period and this glacial period, this cold period, cold arid period, they are producing more dust as compared to this interglacial period, because interglacial period mostly it is moist environment, there are fluvial sedimentation was more, but in glacial period this is totally dry. So, there was more chances of wind activity and this dust productions. So, that is why comparing the interglacial and glacial period is more prone to develop dust or the silt and clay size particle as compared to this interglacial period. Loess, it is mostly this loess terminology comes from the luge, unconsolidated. So, loess has an aeolian origin, much of derived from glacial outwash and other alluvium or from desert, although minor water transport, mass wasting and pedogenic processes are accepted as part of the overall process of loess accumulation. Loess, it is the loose material, loose unconsolidated material, mostly it is of silt and clay, mostly it is silt and less is clay. So, these are this product of either glacial outwash, that in deserts and alluvial sediments. So, due to reworking by wind, these finer dust particles they removed and very less contribution is from fluvial sediments and it is forming loess. So, nowadays whatever the loess ridges you can see in the Punjab, Haryana, Uttar Pradesh and somewhere else. So, mostly they are representing these silt size particles derived from this wind, derived by the wind activity from the surrounding arid region, and for Indian context it is from Thar and from the Ganga plain during this climate change. Most of the world loess is dominantly silt size quartz to that is mostly 20 to 60 micrometer, but reflected the lithology of the source terrain and may be highly calcareous. The abundance of quartz indicates a source area weathering, that weathering process should have removed these ferromagnesian minerals, the micas, these other type of minerals or the feldspars, and such type of erosion, but that means a particular type of erosion which is responsible for enrichment of quartz in the source area. So, here you can say this the silt or the clay, that the finer material is blowing out of this desert periphery and deposited where there is a decrease in wind speed, and finally, it forming the loess, and mostly the world loess, it is composed of silt size particle and it is responsible for the deposition during this climatic change. So, I think we should stop here, and the next class we will discuss with the different topics. Thank you.